Hopefully not. We'll see. Okay, for this example right here, we move on. We're in the middle of substitution. We don't need to do the introduction more. We actually established you guys have a fair understanding of substitution based off the lesson yesterday, right? So let's look at some other problems that maybe are not quite as intuitive. I want to know this antiderivative. And as you see, it looks like a very complicated antiderivative. Not going to be that big of a deal. Anybody would know what we choose u to be? Square root of x is the right choice. If you notice, square root of x sits on the inside of the cosine function. Square root of x is correct. And so we say du is the derivative of the square root of x. This should be 1 over 2 roots of x dx. Now, I don't have a 1 over 2 roots of x. Notice I do have a square root of x in the denominator. That's a good sign. I also have the dx, but I have a negative 2 and a positive 3. So what could I do to this? Let's forget about the 3. What could I do to this to create a negative 2 up top? Multiply by a negative 4. Negative 4 du is equal to negative 2 over the root of x dx. So that created a negative 2 on top. I'm almost there. Divide by 3 now on each side. All right, so we got caught up there. I'm going to do my substitution, negative 4 over 3 du. Sometimes people ask the question, do they have to include the du? Yeah, I mean, that's an important step in the problem. That's part of your substitution. Integral, and if I plug in a negative 4 over 3 du, what do I get to cross off up here? Negative 2 over 3. Root of x in the bottom, and dx is gone. What remains? Cosine of u. Now the problem is easy. The antiderivative cosine is positive sine. So we have negative 4 over 3 sine of the root of x plus c. Yes. I have a 1/2. If I multiply both sides by 2, I would just have 1. If I multiply by 4, half of 4 is 2. Then I wanted to come up with a 3 in the denominator, so I just divided both sides by 3. You could do it the other way too. You could say, we could just take this and say, I want to get rid of the 1/2. So I'm going to multiply it by 2. 2 du is equal to 1 over the root of x dx. And you could just start there. Then you could say, well, I want a negative 2/3. So now I'll multiply by negative 2/3 times negative 2 over 3. And now you get negative 4/3 there. So multiple ways to look at dealing with that constant. So, okay, the next one, I continue to forget this, but this problem is extremely difficult. And so we're just going to do not tangent squared, but tangent of x. If it's tangent squared, that becomes a really complicated problem. I don't know if we can do it. I don't know if I could do it. U is equal to, anybody? 4 plus tangent of x. What is the derivative of 4? 0. What's the derivative of tangent? Secant squared of x dx. So you have to know all of your derivatives and your antiderivatives for the test. Notice that I get to take care of, as I write down integral du, what do I get to cancel out up top? Yep, that's gone. What remains? U cubed. Simple antiderivative. What is it? U to the 4th over 4 plus c. We don't leave u. What do we put in its place? If you wanted to check your answer, you could take your derivative using the chain rule, and you should come out with what we had before. Notice how that's how we started this unit. We said take the derivative and see if you come up with what you're supposed to. That's how we started, so you could have the opportunity to check your answer. Okay. All right. Try a couple more. I think that is, tomorrow we try more challenging ones. We're still at a foundational level. So on a scale of like 1 to 4, we're at about level 2 now. Okay. So we did kind of level 1 stuff yesterday. We're getting a little bit more level 2 stuff right here. So number 5 looks a little bit complicated, but it's not too big of a deal. Anybody want to guess what u can be? 1 minus x squared. Now, it's as you think about what you should choose u to be, some people say, well, it's always the thing on the inside. That's one way to look at it, but here's another idea. You want to choose u to be something such that when you take the derivative, you come up with something else. So watch what happens if I do du. What's the derivative of 1? And the derivative of negative x squared? Negative 2x dx. So I like this because I came up with an x dx. I don't care about the 3. I don't care about the negative 2. I can always play around with the integers and make them do what I want, right? But the x and the dx, that's really important to come up with. So I need to come up with a 3. Maddie, how are you going to come up with the 3? Divide by? Very good. And so we get negative 1/2 du is equal to x dx. But I don't have an x dx. I have a 3x dx. So what are you going to have to do still? Multiply by 3. So we get a negative 3/2 du is equal to 3x dx. So I work with the constant. Okay. So negative 3 over 2 integral du. What goes in its place? What do you get to cross off? 3x dx. That's gone. And what goes in place of 1 minus x squared? U goes in for 1 minus x squared. So what remains here? 1 over the root of u, right? Or u to the negative 1/2. What is the antiderivative of u to the negative 1/2? U to the 1/2 divided by 1/2. So I'll write it out so that people don't lose that, but I get negative 3/2 times u to the 1/2 divided by 1/2, but instead of dividing by 1/2, we can multiply by 2. So you can see the 2's are going to cancel. We get negative 3, u to the 1/2 will be square root of 1 minus x squared plus a constant. That's your antiderivative. You try number 6 on your own. Go. You can do it. You're smart. Believe in yourself. I believe in you. Yeah.
I was doing this yesterday. Like, it makes it a lot easier for me to...
Oh, sure. Yeah. Yeah, I like that.
No.
All right. Pause. Check it out. Did you get 2 integral u to the negative 3rd? So then we have 2 times the antiderivative of u to the negative 3rd is u to the negative 2 divided by negative 2. So notice in this situation that the 2's will cancel there, and you get negative 1 over the quantity x squared plus x minus 1 squared in the denominator. Okay, last two, then you're going to have about 12 minutes. Time to get some work done. Thoughts on number 7? Should I choose u to be e to the x, or should I choose u to be e to the x plus 1? Have a conversation with the person next to you. What should I do? Go. All right, let's see which one we choose. If I choose u to be e to the x, what is du? E to the x dx. So if I choose u to be this, then I don't come up with this thing on the bottom. So I don't like that choice. But if I choose u to be the bottom, then du is equal to e to the x dx. That does give me the top. So this is the correct substitution. We're going to let you two work together on that. So I've got the integral dx, or du. I get to get rid of the e to the x and the dx. What remains? 1 over u. What is the antiderivative of 1 over u? Natural log. Notice that if you try to watch it, because this is important. You see, this is a challenging piece here. If you have u to the, this thing is u to the negative 1, right? If you add 1, you get u to the 0, and then you divide by 0. That doesn't work, does it? Yeah, so you got to memorize that the antiderivative of 1 over u is the natural log. And the natural log of e to the x plus 1 plus a constant. Okay, last one. You choose for the next one. Should u be equal to sine or should u be equal to cosine? Have a conversation with the person next to you. Go. Yes. Five, four, three, two, one. The correct choice is u is equal to sine of x. And here's why. If I choose u to be cosine, du is equal to negative sine of x dx. I don't come up with sine squared, do I? That does not help me. But if I choose u to be sine of x, then du is equal to cosine of x dx, which is exactly what you have right here. Just watch. Okay? So I'm going to choose this substitution. U is equal to sine of x. So I notice I have a cosine and a dx, but I have a 4 as well. So what should I do? So multiply by 4. So I have a 4 integral du. As I set up 4 integral du, what do I get to cancel off? 4 cosine and dx. What am I putting in the place of sine? U. So it's going to be u squared. As long as I'm left with something that I could take the antiderivative of, we're fine. And the antiderivative of u squared is? Yeah. So I'll have 4 u to the third, or 4 sine cubed, over 3 plus c. And that's your introduction into substitution. You've seen the level 1 and the level 2 problems. in your homework, if you check out your homework packet, I think that it would be very good of you
I'm tempted to do it.
I think it'd be really good of you to start looking at problems 1 through 16. If you feel like moving further ahead than that, if you're a student who got a little bit far and studied all yesterday, then maybe 1 through 24. But problems 25 through 32, some of those we kind of need some time tomorrow before you really understand those. Okay? Yep. So, give you guys some time there. Try to knock off a few problems. And I'll answer a few questions here.